Welcome back, Algebra 3. We are in Lesson 22. We're going to talk about absolute value and reciprocal functions. So 22a, absolute value. We're going to just jump right in and start graphing. Let's do these example problems and so you can kind of see where we are and what we're doing. And we've done this before, but we want to refresh our memory on how to do this. So our instructions here say for us to graph the absolute value of x minus 2 is equal, is less than 0. So we are graphing inequalities on the real number line, and we're using absolute value. So these where the x is the absolute value, we understand how to do those. We know that the absolute value means that it could have a positive value of x or a negative value of x would still be the same value when it comes out. So we're going to do this two different ways to see all the possible values of x. And the way we do that is by using both a positive value of x and a negative value of x in order to solve for all the possibilities. So for our positive value, all we do is we write it the positive version of x from outside of or from inside of the absolute value. We just remove the absolute value here. And then we do the same thing by making it the negative value of x inside, or the opposite value of x. So then we go ahead and solve by adding 2 to both sides, and we get that x is less than a positive 2. Here we add 2 to both sides, and we get that negative x is less than a positive 2. We have to get rid of this negative sign, so we multiply everything by a negative 1, and that's going to be a positive x is greater than a negative 2. And that allows us to graph that inequality together. We see, first of all, we have a positive 2 being identified and a negative 2 being identified. And we have to ask ourselves some questions. First of all, is that number included? It is not. So we're going to draw a circle on each one and just leave them open. Then we have to find which direction the line is going. Well, if x is going to be less than a positive 2, then that line is going to go to this side. Let me change colors just so you can see what I'm doing. We'll go to this way, to the smaller or less than 2. And if x is greater than a negative 2, then it's going to go this way. So the inequality is going to be written, or the solution set is written, where x is going to be a member. Here's our domain. X is a member of the set of all real numbers such that negative 2 is less than, or this is not equal to, so less than x, which is less than a positive 2. And that's how we would write the domain for this function or this inequality. That's how we would write that up here. Okay, so we can see how to solve those where the x is the only thing, the variable is the only thing within the absolute value. So now we have to address a situation where x might be in an expression within the absolute value symbols. We're going to do that in 22.2. So if x is an expression x minus 5 is less than 2, we're going to graph this set where x is a member of the set of all real numbers such that the absolute value of x minus 5 is going to be less than 2. So we've got to find the solution for this and then graph it and rewrite it. Okay. So let's do that. So here we would have both the positive version. The positive version is x minus 5 minus 2. And the negative version would be the negative of all of this. So -1 times x minus 5. And it's what we have to do in order to get the opposite. So that'd be less than 2. Now notice the -1 is only being applied to the absolute value here, the positive. So it'd be -x plus 5 is less than 2. Now we can solve these. So we are going to add 5 to both sides here, and x is going to be less than 7. And then we're going to subtract 5 from both sides here. -x is less than a -3. But then we multiply everything by a -1 to get rid of the negative sign on the x, and we find that x is going to be greater than a +3. So we are going to draw that on our number line. We're going to identify those numbers. Here is our +3, 4, 5, 6, and then our +7. All right, so we are going to first of all look at this x is less than 7. So we circle the 7. Let me use a different color. I always forget to do that. We circle the 7. X is greater than 3. We circle the 3. If x is greater than 3, it's going to go this way. If x is less than 7, it's going to go this way. They're going to meet each other. And x is going to be written as 3 is less than x, which is less than 7. And that is what we would put up here. That is our solution set, such that 3 is less than x, which is less than 7. It would take the place of that. All right, so let's look at something that has a less than or equal option with it. Let me clear this. Right now in 22.3, we have graph the set. Here's the set. X is a member of the set of all real numbers such that x plus 2 is greater than or equal to +3. So we're going to do the exact same thing we did before. We're going to take the positive version of this. So the x plus 2 is greater than or equal to 3. And then we're going to take a negative version of this. And that's going to be -x minus 2 is greater than or equal to 3. So now subtract 2 from both sides. X is greater than or equal to +1. Over here, we're going to add 2 to both sides. And -x is greater than or equal to 5. Multiply everything by -1. X is less than or equal to -5. All right, so now we take these two and we graph them on the number line. And you'll note here we have a disjunction. So I'm going to put -5 here, and I'm going to put +1 here, and here's a 0, just for reference. 1, 2, 3, 4. And I'm going to switch colors. X is greater than or equal to 1. So or equal to, greater than would be this way. Now x is less than or equal to -5. We would circle and fill it in. And x has to be less than -5, so it would go this way. So this is a disjunction. So we would write that a different way. We would say x is greater than or equal to 1, or x is less than or equal to -5 within this set. Okay. All right, so let's move on to 22.4. Let's clear the page. In 22.4, we are asked to graph y is equal to the absolute value of x. So why don't we come down here to our graph paper and do that? All right, so if y is equal to the absolute value of x, then we're going to need to make a little table to show us how to do that. So again, like our function machine, we're going to just draw a little table. We're going to put our value here, our function here, and then we're going to put y here, okay? So if x is -3, absolute value of -3 is 3. If x is 0, the absolute value of 0 is 0. If x is a +3, the absolute value of a +3 is 3. So we have 3 points here, -3, 3, 0, 0, and +3, 3. So that is going to look a little something like this. We have our origin is one of the points, and then we have a -3, 1, 2, 3, 1, 2, 3. And then we have a +3, 3, 1, 2, 3, 1, 2, 3. So this line, this function, is going to look something like this. Given what we know about functions and relations and one-to-one functions, we can say that this is a function, but it is not a one-to-one function, because it will pass the vertical line test, but it would not pass the horizontal line test. So while it is a function, it is not a one-to-one function. Okay? All right. So let's look at reciprocal functions and how that works. Let me clear this for us. So if the original function y is equal to x, if that's the original function, then the reciprocal function to that would be y is equal to 1 over x, because if this is a whole number, it'd be x over 1, right? So the reciprocal, if I can spell it, is going to be y is equal to 1 over x, because reciprocal means inverted or upside down. This creates a vertical asymptote. That's a name that you need to, or terminology that you need to understand what that is. Vertical asymptote. It's a vertical line that is approached by the graph of a function as x approaches a fixed point. The graph of the reciprocal function has a vertical asymptote at every place where the graph of the original function intersects the x-axis. So consider y equals x. Okay, we would have a table here. Here's x, and here's y, and y is just equal to x. So whenever I pick for x, 0, 0, 0, 1, 1, 1, -2, -2, -2. Whenever I pick for x, that is the value of y. So the graph, the corresponding graph, would look a little bit like this. I could say x and y are the same thing. So +1, +1, +2, +2, +3, +3, -1, -1, -3, -3. So you would have a positive slope at a 45-degree angle with a slope of 1 over 1, right? That would be what your graph would look like for y equals x. That's what that is. But then if we reverse it, let's say we do y is equal to 1 over x. This is the reciprocal of this one. Let's see what we end up with. So for our x value, and then we have 1 over x, and then we have our y value, right? So I'm going to go ahead and draw our little graph here so we can understand what a vertical asymptote looks like, and then we'll pull out our graphing stuff. So we have x, let's say x is 1, right? So 1 over x is going to be, it's going to be 1 over 1. So that's going to be 1, right? So our first point is 1, 1. So we would put our point here, 1, 1. Okay, so far so good. Our next point, let's say it's 2. Excuse me. So 1 over 2 would be 1/2. So our next point is going to be 2 and 1/2, right? So we would say 2 and 1/2. So it stands to reason that at 3, it would be 3 and 1/3. And at 4, it'd be 4 and 1/4. And at 5, it'd be 1/5. So it would always be a fraction where the denominator is whatever the number is on the x-axis. So it would approach the x-axis, but never cross. What if we put in a fraction for that? What if we said 1 over 2, right? And then we put 1 over 2. Well, how do we get rid of a fraction divided by a fraction? We say 1 over 1 divided by 1 over 2. That's going to be 1 over 1 times 2 over 1. So that'd be 2 over 1, which is a whole number 2. So the answer would be 2. So if x is 1/2, then the y is 2. So that would mean 1/2 and 2. And we can use that logic to know that 1/3 would be 1/3 and 3, 1/4 and 4, 1/5 and 5. So it would approach the x-axis, but never, ever, ever, ever cross it. And because we just dealt with positive numbers there, we have to assume, it makes sense, that if we substituted in negative values, we would have negative, negative, right? Because if this were a -1, this would be a -1, this would be a -1. So that means that we could do the reciprocal right underneath, right? It would be the same exact thing, I think. Yes, it would be the same exact thing. We would be getting closer and closer and closer to the x-axis, but we would never actually touch it. And we couldn't use 0 because 0 would make this indeterminate. So for a reciprocal here, our domain would look like this. X is not equal to 0. That would be our domain. But then we would have these descending values of the y or the x, depending on whether it's a fraction or a whole number being substituted. And so we would end up with 2 vertical asymptotes that approach the x-axis and the y-axis, but never actually cross it. Okay? So that's what you would have with something like this, right? That is called a vertical asymptote right here. All right, let's move on to 22.5, and we are going to have our own little vertical asymptote, or reciprocal. And 22.5 says to sketch the graph of the function y equals 1 over x squared. All right, so now that you understand what you're doing here, okay, I would allow you to use your graphing calculator to get there, right? But you're going to want to have some points that you can check to make sure that you understand what you're doing. So I would say make a few points here. That's what I would do. 1 over x squared, right? And then this is your y. So if we know it can't be 0, x cannot be 0. It can't be, because 0 can't be on the bottom. But we could start with 1, and 1 times 1 is 1. So 1 over 1 would be 1. And then if we did 2 for the x, 2 times 2, that'd be 1 over 4. So that'd be 1/4. That'd be, 2 squared. So then if we did 3, that'd be 1 over 3 squared. So that'd be 1 over 9. Okay, so now we have some points to check. So you can pull up your graphing calculator after you have a few points to check and double check your work and make sure it's right. So y is equal to a fraction where we have 1 on top and then we have x squared on the bottom, and that is going to be this vertical asymptote here, and you can just shrink it down like this. So this vertical asymptote actually goes this way and then it goes this way. We didn't do any negative signs, so that's probably one of the things that you ought to do as well when you're creating this, is do some negative points. Whatever positive points you pick the negative points to go with it and see how it affects your answer. I'm gonna, if I scroll in really tight and magnify it, I can see exactly what it does. Let me get it to where it's in the single digits here. All right, so now we have single digits, the number line. So we can see right here, 1 and 1, right? 1 and 1. And then if we had done this -1, that'd be 1 over -1, which would be a -1. So then that would be -1. 1 and 1. And -1, 1. Okay. All right. So those are some things that you're going to want to look at. And the reason this is a +1 up here is because this is squared. So a -1, if this were -1, -1 times -1 is a +1. So it would be a +1, right? So that is the thing that you have to think about. If we have something squared, then you're not going to have any negatives. So everything will be above the x-axis for your y values. You might have some negative x values because you can select a negative x value, but you would not have any negative y values because a negative times a negative is a positive. So all your y values would be positive up here because that would be the x value squared on your denominator. All right, so use the table to create your points, right? Use the graphing calculator to input your function, and then you can analyze it and see, okay, did my points that I selected line up? Okay, now look at 2 and 1/4. You see how this is divided 1, 2, 3, 4, 5. The lines here, it's dividing this up. That's right there at 1/4, right? Look at that. This is right here at 1/9. This is here at 1/16. This is here at 1/25. You can enlarge that to the point where you can check your answer, right? So this is halfway between half and 0. So that's 1/4 right there. So 2 and 1/4, which is this point here, it is possible to check that. All right, just zoom in a little bit tighter and double check your work against what the graphing calculator tells you, and you can see if you're on the right track and know that you understand what's going on. All right, and that's all I have for lesson 22. Yes, lesson 22. I will see you in lesson 23.